Hello and welcome back to our Python for Data Analysis course. And in this session, we're going to be looking at importing libraries that we'll be using for our data analysis work. The first library we're going to import is the OS library, and it contains operating system interfaces that we would use for our data analysis. And so I'm going to run the import command and OS. And here is a link that will take you to the documentation for this OS library. It contains a lot of functions that you can use to interface with your file system and working with directories and things of that sort. So the first command we're going to run is the get cwd function, which essentially means get the current working directory. And so we see that I'm in the Python for data analysis directory on my desktop. The next thing that we are going to do is I want to list the files that are in my current working directory. And so in the OS module, there's a function called the list dir, and then you put the directory name in there. And so what I'm going to do is I'm going to put get cwd, which will return my current working directory, and I'm going to list the files in that current working directory. And so over here, it shows all the files that are in my current working directory, and you can compare and see that they match up to all the files here. The third function that I'm going to use is chdir, which is to change directory. And so here I have a folder called my dir, and so I'm going to change the directory to my dir, and I'm going to run os.get the current working directory. And that tells us that we are in the my dir directory over here. Now, if I go ahead and list what is in that directory, it contains some videos that I've been recording. Now, if we want to go one level up, then we can run the chdir. And if you've done any work with Unix command line or Linux, you can quickly recognize that this two periods and a forward slash means that we're going one directory above. And so I do the get current working directory, and we are back in the folder that our working folder, which has all our notebooks. The next module I'm going to import is a math module. And similar to OS, I put the link for the documentation for this math module, which contains different mathematical functions. What I'm going to run here is the cosine function and then the pi uh, constant. And so those who have some math knowledge know that pi over 2 in radians is the same as 90 degrees. And so this should give me 0 or a very small number, which is close to 0. Another way that you can import functions from modules is using the from keyword. And so if we don't want to import the whole module, in this case NumPy or numerical Python, what we can do is we can say from that module, import the function that we're looking for. And the function we're looking for here is the mean. Mean is essentially going to calculate the average of a list of numbers that you would put in there as the input. So I'm going to run this. And if you remember, we had our country population dictionary, which had different countries and their populations. What I'm going to do here is I'm going to create a list from the values of this dictionary and then run the mean function on the list of values. So the average population of these 5 countries is about 99 million. The last module that we are going to import is the Pandas module, which we'll be using very, very heavily for our data analysis. And there are 2 data structures which we're going to look at extensively in the next video. And those are the data frame and the series data structures. In this session, we're going to start delving into Pandas data frames and series. Now, a data frame is similar to a table which contains rows and columns. So rows are unique records or records in a table which are defined by the column names. So for example, in row 1, we have a patient ID, appointment ID, and so on and so forth. And the Pandas data frame is an abstraction that utilizes rows and columns. A series is a single column of a data frame. Now, there are many different ways to create Pandas data frames, and I put a link here that will show you how to create Pandas data frames from lists, from dictionaries, from NumPy arrays. But then in this video, we are going to read or use the Pandas methods, read CSV or read Excel to read our data into a Pandas data frame. And so remember, we have imported Pandas as PD, and then we import NumPy as NP. And so over here, what I'm doing is I'm calling the function read CSV, and I can type this again. So pd.read CSV. Now, if you look at this, I press tab, and then it pulls up all the different functions that start with read. And so it shows that it can read so many different types of data. So all these are different data types that it can read. So it can read from a clipboard, from CSV, from Excel. But in this case, our file is a CSV file. And so we're going to read a CSV file. Now, CSV means comma separated values. And so we're going to read no show appointments, Kaggle May 2016.csv. And this is how a CSV file looks like when you open it in a text editor. It has each element in here separated by a comma. And so when you open it in maybe your Excel or something, it interprets the comma as a unique column. And so I got this data from Kaggle. And so Kaggle is a website where you can find a lot of data analysis and data science related competitions and other good resources that can help you, grow as a data scientist or as a data analyst. And so I picked up this data set from the Kaggle website, and we can read the context here. It says a person makes a doctor's appointment, receives all the instructions, and no show. So who is to blame? So over here, we're going to look at this data set which contains, a few 100,000 records of appointments that were made, and then different characteristics of those who showed up and those who didn't show up. And so we're going to summarize all of these values, and then this is what we're going to do our data analysis on to see if there are some specific characteristics of those who show up for appointments or those who do not show up for appointments. And so one thing I like here is, there's context to the data set, and then there's a data dictionary which gives or explains what the different columns mean. And so we have a patient ID, an appointment ID, gender, the actual date of the appointment, and then so on and so forth. All right, so let's go back to our notebook. And I'm reading the file into a Pandas data frame, and then I'm storing that data frame in this variable called df_hospital appointments. And so I run this code. And another thing that you can do is I have an Excel version of this file. And so we can do the same thing, store it in df_excel variable, and use pd.readExcel, no show appointments, but this is a .xlsx. And for Excel files, you have to specify the sheet name.
So you can either specify it by using an index. So the first sheet will be sheet name 0, and then 1 and 2, and so on and so forth. Or if you have the sheet name, you can type the sheet name in single quotes, and that should give you the sheet that you're going to read into. So after reading our data set into a data frame, assigning it to this variable, one thing that we can do is let's check what data type this is. Let's not assume it's a data frame. Let's check what it is. And there we go. It's a data frame. So if you recall, certain Python objects have methods associated with them. And Pandas data frames are no different. And so one thing you can do is go to the Pandas documentation, and you can go read a lot about the different files that you can read into Python, the general functions for data manipulation, and so many other features. Over here there's a data frame, and this shows all the different attributes and methods that are inside or that are associated with a data frame. And so what we're going to do here is we're going to run the head method. And so the head method will return by default the top 5 rows of your data set. And so here we have a patient ID, appointment ID, and so on and so forth, like in our CSV file. And then we have labels for each row, unique labels for each row, which is called the index. And so here it shows index from 0, 1, 2, 3, 4. And these rows can be labeled as anything, which we'll see, in a future lesson. The next thing that you can do is you can look at the bottom of your data set, which will show the bottom 5 records of your data set. And so this already is showing us that we have about 110,000 records in this particular data set. Now, to be absolutely sure what the size of your data set is, you can run the shape attribute. And so this attribute stores the shape of the table. So the shape is simply the rows and the columns in that order. So this data set has 110,527 rows and 14 columns. Now, if you want to look at some more information about this data set, you can run the info method. And the info method summarizes, most of the things that we've seen so far with some additional data. So first it's telling us that this is of the class data frame, which we saw earlier. It's showing us that the index is a range index type, and it ranges from 0 to 110526, which we just saw. And then it's showing us that the data columns are 14. And then it goes on to list the columns. It lists how many of the columns are not null, meaning that there's an actual value in those columns. And then it's listing the data type of the column. So it's saying that the patient ID is an integer, appointment ID is an integer, gender is an object, schedule day is an object, appointment day is an object, age is an integer, and so on and so forth. Another function or method that we can run on the data frame is a describe method. And what describe does is it gives us some basic statistics about the numerical columns in your data frame. And so this describe works only on the numerical columns. And so we can see the counts, the mean, standard deviation, the minimum, the maximum, and then the first the different quartiles, the first and the third quartiles, and the median. Now, one thing that you can notice here is that the minimum age is -1, and so that's a data quality issue that we have to look at whenever we go deep into our data analysis. But for now, we'll leave that out. The next thing I'm doing here is I'm finding how many unique patient IDs are there, and I'm picking out a function from NumPy and applying it to the patient ID column. We'll look at this into more detail later. Don't worry too much about it. Now, what about how do we summarize categorical variables? So for describe gave us a summary of the numerical variables, but then if we want to look at the categorical variables, for example, gender, and see what's the split between male and female, we can run value underscore counts and then access the gender column, and then it gives us a breakdown of female is 71,840, male is 38,687. So that's how the data is split by gender. Now, the next thing we're going to look at is how do we select rows and columns in a data set. So we select rows and columns using the square brackets. And so this first line of code is saying that give me everything from 0 up to 3, up to but not including 3. And so it's saying that it gives me labels 0, 1, and 2. Now, if you take out the 0, Python still understands that start from the very beginning and give me all the labels that are 0, 1, and 2 up to 3, but not including 3. Now, we can also look for index ranges that are in the middle of the data set. And so this is saying that return label 5 up to but not including 10. So it gives me label 5, 6, 7, 8, and 9. And then the final one says that give me from label or row 100,000 all the way to the end. And so that gives me from 100,000 all the way to the end. Now, if we want to select columns, what we can do is, still using the square bracket, we put in the column name in single quotes. And so we want to select, for example, the patient ID column. And so what we can do is, let's assign this to a variable and call it patient ID. And then let's look at the type of patient ID. Now, patient ID column by itself is a series. If you remember when we defined series up here, we said series is a column in a data frame. And so that's why it's returning the data type as a series. All right. Now, one of the other attributes that you can run on the data frame is a columns attribute, and that gives you all the different columns in a data frame. If you would recall, we run the describe method on our data frame, and over here what I'm trying to do is to find the type of that describe method, because remember that everything that Python returns is an object, and that object will have some properties or a data type, of which one of them is a data type. And so the describe method returns a data frame. And so if it returns a data frame, that means that it has the columns attribute. And so what I'm trying to do here is I'm creating a list of columns which contain only numerical columns. And if you recall, the describe method only returns numerical columns like we saw here. And then I'm picking out just the column names for those numerical columns. Now, the reason why I'm doing this is because I wanted to create a list of column names that I could select from my main data frame. So here I can assign this to another data frame, which I'll call numerical columns. And then if I did df underscore numerical columns dot head to show us the first five rows, then we have only the numerical columns show up. In our next set of videos, we would look at how to select both rows and columns from a data frame. But for now, I would suggest that you go ahead and go over this video, practice a little bit more. And then if you don't understand anything, you can Google it, read a little bit more of the documentation. You can ask some more questions, and I can explain in later videos what these things mean.